Let's explore how I have engineered regression-based machine learning pipeline to forecast a location's temperature. So it's a weather forecasting project, a regression problem. My place of interest is Chennai. This is just a short-term weather forecasting project for study purpose to predict the next 3 days maximum temperature using the historical weather data collected from Open-Meteo API. This is a time series problem. Okay, so when we take a problem statement or an objective to satisfy or a project to name it correctly, we should never dive into the technicalities right away like coding. We should not start with coding. We need to sit with our objective, understand it, imagine it, plan it, and then execute it. Like that, we will go in the granular level of understanding, like what we will do with this time series data. So we will see lots of explanations also along with the code, and particularly the reason behind our prime step feature engineering. Feature engineering is the most important step, so we should not make any mistakes and we should have proper reasons of why we are doing so and how we are doing it. So the overall objective of this is to build a supervised regression pipeline where previous weather patterns are used to predict the future temperature values. For modeling purposes, I will be experimenting with multiple regression models like linear regression, rich CV, Lasso CV, random forest, and XGBoost in particular to compare both the linear and non-linear behavior. So during this talk, we will walk through the complete technical pipeline, explain the reasoning behind the major design decisions, and compare our model performance and discuss limitations too. Okay, so this is going to be with the real data and with the machine learning, multiple regression models for accurate temperature prediction we will try to achieve. Then the high performance, robust evaluation, model selection using industry standard metrics, and finally our main inference will be 3-day forecast, which is a recursive forecasting to predict the next 3 days. So this will be our final objective. The star performance are like I will say the key features. Okay, so one is the data from Open-Meteo API. For this we will send an API request and collect the JSON response and make it as a data frame, and we will be using it further. So that data from Open-Meteo API, then advanced feature engineering. We can see the features, right? Calendar features, cyclical encoding, lag features, and rolling averages. So why, how, and when are we going to use this, we will be seeing one by one. Then multiple ML models and comprehensive evaluation. These are the evaluation metrics, and the model versioning we will make it as a reproducible one and a scalable one, and finally we will discuss about how this is a production ready, how we can make it as a production ready pipeline. Okay, so the models and the tech stack is Python, the major is pandas, scikit-learn, and XGBoost to mention because our star performer. We will see whether XGBoost performs well or some other model performs well. So this is our tech stack. This will be our free weather API, openmeteo.com. So here in the API docs, we can get to know what are all the things this API can offer. Okay, so here we can see the location, so that we have to send the coordinates to get the exact location. The latitude, longitude, and the time zone is very much important. We will be having it as our parameter to configure our API also. Next, here they have given us hourly weather variables, daily weather variables. So for our regression problem, I have taken the weather variables, weather code, and maximum temperature, minimum temperature. Then I have taken the rain sum, that is the precipitation sum, and finally wind speed, that is the wind speed here, the maximum wind speed. So these are all the major variables I'll be using. We will configure these parameters and we will send it to the send it during the API request call. Okay, so what I want to show here is this is the API documentation. You can find the parameter and its description here. So daily variable, hourly, and even we'll be having the 15-minutely parameter definition also. So okay, following that, see here they have given us on success of our API request, the response will be a JSON object. right? So this will be that. So the latitude, longitude, the and time zone are the parameters we will be sending, and the hourly will be daily for us. Okay. Now we also have weather variable documentation. Okay, so this is a weather interpretation codes. For 0 it will be clear sky. We will have a particular feature called weather code, and it will be of numbers, but we need to know what that code means. It is, we should not consider it as a number, plain number. So the number has a particular description, and that will be very much helpful for our forecasting. So we will be using a YAML file. I have taken this code in a YAML file so that it will act as a dictionary where the numbers will be the keys and this will be the values. So we will also load the YAML file and we will map it to the feature column. On starting, we are going to import the libraries, requests to send and receive the API, next the pandas, numpy, and datetime to work with the date columns and time. So here, next after importing, this is an Open-Meteo API call request to get the historical data, right? So here I have given the latitude, longitude to say start date and end date, right? So this will act as the configuration we needed to request the historical weather data from our API, that is Open-Meteo. The latitude and longitude and time zone are the primary coordinates to reach the location and get at the exact time zone. So for me, the desired location is Chennai. I have given the latitude and longitude. The time zone will be Asia, Kolkata. The start date will be, I have taken a very longer period, 10 years of data. So why I have taken a longer period is, a longer period will help the model to learn the annual seasonality and patterns that changes every year, and from that we can understand, particularly the model can understand the year to year variations. Okay, so as start date I have given 2015 1/1. Even the start date also we can, instead of hard coding here, we can add it to the YAML file and we can load it here. But I have given it directly in the notebook. Next, the end date will be the current date. In production pipeline, we have to use the current date if we have a scheduled ingestion. But for study purposes, we can set the cutoff date as they will differ every time we run. Right? So, but I have taken the scheduled, like the current date, like we are doing in a scheduled ingestion, because anyhow we will be saving the data set for reusable purposes. But every time I run, even if this project is going like 10 days 12 days, I have to get a current date, because there is no use of predicting 25th days temperature on 30, right? So I'll get the current date with the date today, strf time. I have mentioned the date format, so this converts it to the API's date format. Okay, next the daily variables, we can offer it as a list or as a string separated with commas here. So this is our configuration needed. I will run this one. Next, preparing the function for data ingestion. So get Open-Meteo data. So I have taken latitude, longitude, start date, end date, vars, which through which we will send our daily variables, and finally the time zone. So this is the URL, right? Open-Meteo's historical weather API endpoint is this URL. So the parameters that we have to send, I've taken it as a dictionary. I will pass these arguments here, so I can access them through latitude, these keys, right? So to send a request, we need to send an HTTP GET request, right? That is possible through this requests. So requests.get, I'll send the URL and the params. The params are here, archive params. Then finally the timeout, so that if it is unresponsive for more than this particular time, we can return back. So I will store it in a response variable in case if our API request, that the HTTP request which we are sending raises an exception. We don't know. So we need to know what an exception has been raised. So for that I will use raise for status from the response. This will give the exception, like timeout exception or something like that. Whatever exception we are getting, we will get notified. Next, as we have seen in the documentation, the response will be in the JSON format. So I'll get the JSON format and will save it in the historical data. From that, daily is our desired variables, right? These are like common, these are the primary parameters that configure the data set, so we don't need it further. So I will be taking only the daily. So this will have the daily variables, so I will take it from the historical data and convert it into the data frame and store it in daily data variable. So during the runtime we cannot see, like after the cell gets run, we cannot see that after the runtime we cannot see that like what daily data has. So I have printed daily data column so that we can get an understanding what it was in the middle. So that is what. So here time, we will also get time from that, but this time will be what to say, API dates initially arrive as strings, but to work with that we have to change it as pandas date time. So I have taken the time from daily data and convert it into pandas to data time, sorry, date time. That will give us the time column. Here daily data, I have renamed the columns because these are very hard to read. So to improve the readability and for easiness, I have taken like I have renamed these columns. Date as time as date and weather code as weather, and all the other as temp max, temp min, rainfall, sum of daily rain and wind speed, and we will return the daily data. So let's run this one. This function is defined to perform the data ingestion. I will be sending all our configured parameters here. So when this function is called, these data will be ingested here and we will get the daily weather TF. Let's see. API call request is P will be sent. Okay. Bad requests. This is because it's past 12, so today's data may not exist, right? Wait, I have hard coded it. Today's data, today's date. So let's see. So APIs will have data updated at at a particular time. So correctly this is 12 a.m. So this 13th data will not be there. So I will have the data from 12 till 12. So let's run this. Let's see. Okay, we have got it. Yeah, that is the problem. Okay, we don't have any kind of problem with our code, only with the date because of the API updation, and the date didn't exist. Okay, okay. Now, so here we have printed daily data, right? So what we have got as a response is time weather code. No, this is the response we have got. So we have renamed it also. How our daily weather DF looks. Let's see. Let's bring it up. So here we can see the shape of the daily weather DF, that is 4181 rows and 7 columns, and this is how our data will look like. So this is the date, weather, temp max, min, maximum temperature and minimum temperature, rainfall, sum of daily rain, wind speed. Okay, then the info. Through info we can see this is a pandas data frame with entries 4181, 7 columns. See, we have converted it into date time, so it has the data type as date time. Next, weather as int because they are code, right? So and all the other things are float, and we don't have any null values. We can see this from the non-null count. So this is the information about our daily weather DF. Now let's see the min and max temperature, sorry, min and max date. So we can get an idea of what is our start date and what is our end date. So here 2015 1 and 2026 6/12 will be our end date. So till yesterday. And okay, so I have also mentioned the weather YAML file, right? So YAML is not a markup kind of language, right? So it will be sometimes hard coding is not up to the mark in the production level. So it will not be like hard coded, will not, they will not use the hard code things, right? So this is not a markup language, and this is kind of very human readable file format. Okay, so instead of hard coding these values assume that we will be have like, what if we have all these values in our particular cell? So we need to create a dictionary and we need to map it again. So instead we can create a YAML file and we can access it. That is what I have done here. So I have saved the YAML file and I'm going to read it. Okay, so open in a readable format, and as F I'm doing it here, YAML.safe load. This will load our YAML file into weather map, and with the weather map it's a dictionary. So we can see the keys 0 to 99 and we can access through the keys like this. So following this we will see the feature engineering, which is going to be super fun. This is kind of a starter where we have loaded our dataset. So the fun begins when we start the feature engineering. Follow for the next video to get to know more about time series. And so far we have seen the very basic thing which we'll be doing for all projects, but the next thing is completely focused on time series, and the explanation is going to get better. So wait for the next one. That has the feature engineering of cyclical features, that is the seasonal features, the lag, rolling average, target shifts, everything will come under the hood of feature engineering, and we will see whatever that takes, why it took this much of effort. Like feature engineering is the most important thing. So let's see why feature engineering is important and how it impacted our dataset and our modeling also. So let's see one by one. Following the feature engineering, we will be working with the models and we will see how the feature engineering impacted our models a lot. So that is going to be a lot of fun, and we will be also seeing different kind of visualizations. Even for the train test split, we will have splits, and we will using those splits to grid search CV and all. So things will be getting like much more technical. So let's have fun in the next video.